Okay, and last up for section 11.2, we're going to look at question 9 on the worksheet. It says, describe the shaded region below as a polar region. It says the curved portion is a semicircle. Okay, so to describe a region in polar coordinates, okay, it helps to think about sweeping rays through your region. Okay, so to spell out in more detail what I'm describing there, imagine this ray here. Okay, it forms this angle theta with the positive x-axis, okay, and the ray enters into our blue region at this point along the vertical line where x is equal to 1, and the ray exits out at this point, which lies on this semicircle. Okay, so what I'd like to figure out now is that for this rotation angle theta, okay, what is the radial distance r from the origin to the enter point? And what's the radial distance r from the origin to the exit point? Okay, and we can find those distances off to the left. So for the enter point, well, since it lies on the vertical line when x is equal to 1, and x is r cosine theta in polar coordinates, okay, we have that r cosine theta is equal to 1. And so dividing both sides by cosine theta, this says that r is equal to secant theta. Okay, so the distance from the origin out to this enter point is secant theta. And notice you can also see that here from this right triangle. Okay, r is the hypotenuse of this triangle, and the adjacent side to the angle theta is just the base of this triangle. That's 1, right? Because that's the distance from the origin out to the center of this circle. So if I take the secant of this angle theta, I'm going to get the hypotenuse r divided by the base, which is 1, and so r is equal to secant theta. All right, now how about for the distance from the origin out to the exit point? Well, since the exit point lies on this semicircle, whose Cartesian equation is x minus 1 squared plus y squared is equal to 1, since the circle is centered at the point 1, 0, and it has radius 1, okay, note that I can multiply out this x minus 1 squared to get x squared minus 2x plus 1 plus y squared is equal to 1. Subtract 1 from both sides, and those drop out, and move the 2x over. And we're looking at the equation x squared plus y squared is equal to 2x. All right, now x squared plus y squared, that's r squared. And 2x, that's 2r cosine theta. So I get that r squared is 2r cosine theta, and if I divide both sides of this equation by r, I'm left with the equation that r is equal to 2 cosine theta. Okay, so that's saying that the distance from the origin out to our exit point, r, is equal to 2 cosine theta. You see that here in green. Okay, so then, right, the set of all points along this ray that are in our blue region, right, are such that, right, the angle is theta, and the r value can be anything from the low end, right, at our enter point, where r is equal to secant theta, up to the high end at our exit point, where r is equal to 2 cosine theta. Okay, so now we want to fill out the rest of this region, right? Right now we're just describing the set of points on this orange line segment. Okay, so now I want to let theta vary to fill out the blue region with similar line segments. Okay, so the bounds for theta, well, we want to let theta vary from this angle, negative pi over 4. Why is that negative pi over 4? Well, right, we want to consider, right, this ray that just touches this lower corner of the blue region. And notice, right, we have this right triangle right here, and the distance from the origin to the center of the circle, that's 1, and the distance from the center of the circle out to this lower corner here, well, that's also 1, because that's just the radius of the circle. Okay, and so since these two sides are the same, these angles are both 45 degrees, and so theta here is negative pi over 4. And likewise up here, theta is pi over 4. Okay, so by considering all of these rays, as we let theta vary from minus pi over 4 to pi over 4, we're going to be filling out this blue region with a bunch of these line segments. Okay, so these two sets of inequalities here describe our blue region. Okay, so R varies from secant of theta up to 2 cosine theta, and we're letting theta vary from minus pi over 4 to pi over 4. All right, well, that's a good place to stop. I will see you next time. Thanks.